All right, welcome everyone. We're going to go ahead and get started. This is going to be our Engineering OpenShift webinar. My name is Felicia Ward. I'm the Field Solutions Architect for Red Hat. My co-host, who you will also meet shortly, is Marshall Hall. He's our Field Solutions Architect. He does hybrid cloud and Red Hat, so you get the best of both worlds there. I always start with a joke, so I'm going to tell you all my favorite one. So there was a parrot that worked on a cruise ship with a magician, and every day the parrot would sit in on the magician's shows. And after a while, he got to know the tricks. When they saw the lady in half, he would go, her feet are in the other half. When there was a vanishing person trick, he'd be like, it's in the back half of the cabinet, and so on every night. And the magician got so upset with this parrot. One day, the ship wrecked, and all that's left is a magician clinging to a piece of board and this parrot. And the parrot looks around and looks around and looks around. And finally, he says to the magician, I give up. What did you do with the ship? I know that was a little corny, but it's my favorite one, so I hope you enjoyed it. Let's go ahead and get started here. So OpenShift is a containerized platform service, which is what OCP stands for. It is not a VM, but it's like a VM. VMs run, excuse me, VMs are not small instances. VMs are basically like a server in their own right, sitting on top of a computer, whereas OpenShift Container Platform or containers are tiny, and they're just instances of the underlying software, which would be the operating system, and they run in their own right and can be ported around. So here are some of the benefits. You mean it's self-service, it's multi-language, it's enterprise grade, it's secure, which is very important. As you've known from the many webinars that Marshall and I have done on security, everything can potentially provide a vulnerability, but we want to make sure that we're patching those as much as possible. Since OpenShift is immutable, it means that it's hard to change once it's in there. So you cannot exploit that as a vulnerability. So let's go into some of the basic concepts on OpenShift. So a container is the smallest compute unit. It's a lightweight, more agile way of handling virtualization. So instead of spinning up a whole VM, we have containers which package everything you need together to run an image. But in Kubernetes, which is the underlying framework for what we do in OpenShift, it is the smallest thing that can be orchestrated. So the containers are, of course, created from container images. An image is just a set of instructions that tells you what to do, what to put into it, and then you cannot change the image, but you can make as many copies of the image as you want and stand those up as containers. That's why the container image is binary. It's basically in binary code, and containers are runtime, which means that they are able to be used to run your applications. Container images are, of course, stored in image registry. I think that is pretty self-explanatory itself. We have a place where we put all of the similar container images together, and then when we want one, we reference it via a service. So an image repository is similar to the registry. It contains all versions of an image in the image registry. So we might, use multiple different versions of the same image, but they all have different names, and this is a place that keeps them all together. The image base is going to be your repository name. The image tag will discriminate different versions of an image. So the base will tell you, like for example here it says front end, front end, front end. That's going to be the image base. And then the different versions 2.0, 1.1, et cetera, et cetera. Now pods are what's going to hold and orchestrate your containers. So think it's like peas in a pod, basically it's a container of containers. And a pod configuration is defined in a deployment. So the replication controller is going to ensure that the specified number of pod replicas run at all times. So what that means is that there's something in your software in OCP which is watching to make sure that all the healthy pods that you have and all of their copied pods, which is sometimes necessary to make sure that you facilitate a process to have more than one pod running a process, is running the way it should, and that there are the right number that are supposed to be running. If it fails a health check, for example, they'll remove the pod and spin up a new one containing the correct container, which will help keep your applications running smoothly. So services provide internal load balancing and service discovery across pods. So basically what that means is services define a logical set of pods and connect the application components together. So this logical is not human logic, it's computer logic. So it's basically based on the code that sets them all together. And apps can talk to each other via the services. So a Kubernetes service serves as an internal load balancer. So it'll identify a set of replicated pods in order to proxy the connections it receives to them. And so, like I said, pods can be removed or replaced if they fail health checks, if they fail the liveness or the readiness check. So it makes sure that everything is where it's supposed to be, and the apps can talk to each other that way. Now, routes will add services to the external load balancer and provide readable URLs for the app. So Openshift's networking SDN is capable of providing a platform-wide pluggable routing tier to route traffic to the applications. And that is a big fancy way of saying there is a highway basically that connects the services to the load balancer to make sure that everything is working the way it should, that traffic that's coming in is not overloading one set of pods, but that it's being distributed equally across the pods. Projects isolate apps across environments, teams, groups, and departments. So a project is a Kubernetes namespace with additional annotations, and it's going to be your central vehicle by which access to resource for regular users is managed. So it allows you all to do your various work, but without interfering with anybody else's work, which is great because when you're building a big app, for example, like a huge, mega app, you might want to be working on a small piece of the code, but you don't want to interfere with what other people are doing. Like if you're working on the back end, you don't want it to take down the front end. If you're working on, the vehicle by which it pushes out push notifications, like when you do two-factor authentication, you don't want that to interfere with, actually keeping the app running. So we use the smaller instances in projects in order to be able to do that and not have them knock down others parts of people's project. So now we're going to go into a functional overview of Openshift. So this chart I wanted to show you is all the different possible combinations of things that you could use to do what Openshift does in one package. So this is tremendous amount of different things where you have API gateways, you have service meshes, you have different apps for provisioning, you have, all kinds of things in here that do run on Kubernetes or plug into Kubernetes, but they are all disparate packages that you would have to put together instead of being able to get what you need in one OpenShift deployment. So for this one, I wanted to show you what a Kubernetes, or I'm sorry, an OpenShift cluster would look like. So this is an application instance with a OpenShift cluster. So this is a master cluster, which is on the left, and two worker clusters, or I'm sorry, two workers instances on the right. And the three of them make up a cluster. So the master is in charge of the monitoring, the logging, all of that good stuff, and making sure that everybody does what they're supposed to do. And then the other portions of the app instances are in the workers, which actually carry out the job that's supposed to be done. So like it shows here, you have app services like the service mesh, the middleware, the runtimes, and then you have the developer services, which could be CI/CD, the dev tools, etc., all on top of, all built into this automated operations framework, which is your OpenShift. I included this slide because a lot of you might have the questions, like if you look through the documentation online, you'll see that there's mentioned two different versions of RHEL. There's RHEL itself, and then there's RHEL Core OS. The Core OS only runs on the master and the work in the cluster. It doesn't run anywhere else, so it's not something that you can purchase or something that you have to install separately. It's just the underlying framework for the masters in each of your clusters. And then of course you can get the rel by itself, and as you would have inquired if you went to our operations desk or something like that. So rel is our general purpose OS, which goes under everything. And now I'm going to turn it over to Marshall for our troubleshooting portion of this. Marshall, take it away and let me know when to click on the next slides.
All right, fantastic. Thank you so much, Felicia. You did a great job on the first portion, and I will try to follow your lead. So we'll go to the next slide, if you will. All right, so what we've put together is we put together a few slides of some common problems that are encountered during the installation and operation of an Openshift cluster. So there's a lot of other things that could possibly go wrong. There's a wealth of information around troubleshooting. We didn't want to overwhelm you today with the world of possibilities, but we wanted to go through some common scenarios, some common things that are encountered, and discuss how these are put together or how these work at a higher level, so that we can so that you're aware of how these work, what's available for troubleshooting. So the first one we're going to discuss are installation issues. So we have a few different ways to troubleshoot installation issues. The first on the slide here is gathering logs from a failed installation. So if we have an installation that failed completely and didn't make it all the way through the installer, we have a way to gather the information from that installer and determine where it failed. The things that we need to get that information, though, is we need the SSH key that we used on the installer node. So if we don't have access to that SSH key, which is something that we would provide during the installation, so we should have it. But if we don't have that SSH key, then we won't be able to use this first option that we have, and we would need to go to one of the other options. But in the event that we do have the SSH key, we could pull the debug logs, we could pull the information from the failed installation, and we'd be able to see exactly what happened during the installation and where the failures happened, so that we could address those and fix those, and hopefully get a successful installation the next time. We could also use that information that we gathered to open a Red Hat case should we need to do that. The next option that we have is to manually gather logs if we have SSH access to our hosts. So this would be a situation where the installation completed, but we're having some problems with the cluster that aren't, or we see the cluster isn't working properly. So we need to do some troubleshooting. We think there's a problem with the installation. So we're going to manually gather some logs, and we have SSH access to the hosts. So we'll SSH to the hosts, and we'll run some commands to manually gather the log and journal information. And that will help us to understand what happened during the installation and what failed and what we can do to fix those problems. If we don't have SSH access to our hosts, then we can manually gather these logs without SSH access. There's a couple of conditions that we need to have, though. The installation must have completed. The API service has to be up and running on the master nodes, and we have to have administrator privileges. So we have to have those three things going for us for us to be able to do this. But if we can have those three things going for us, then we can run some OC commands to gather the debug information and the installation log information that we need to troubleshoot the problems that came up during installation, and we can see what happened so that we can fix those problems. The very last option is getting the debug information from the installation program. So we can set the flag to have the installation program itself log debug information to a log file in our local directory, and it'll be in the directory that we launched the installation from, and it'll be in this .openshift_install.log file. So if we have a failed installation and we can't use the other three methods, what we can do is we can rerun the installation program with this --log--level equals debug, and we can encounter the same failure again, and then review that log file and see what we're up against. So these are the four options that we have for troubleshooting installation issues. So one of these four issues should be, or one of these four solutions should be able to help you find the problem that you're having with your installation and fix that and move to a successful installation of an OpenShift cluster. Can we go to the next slide? All right. So the next thing we'll talk about is the tuning operator, the node tuning operator. So this really isn't a troubleshooting technique per se, but it can be used with troubleshooting to fix some problems as we encounter them in our environment by tuning the nodes within our OpenShift cluster. So as we see on the slide, the node tuning operator helps us manage node level tuning by orchestrating the tune daemon. So what this does is it sets a series of parameters for tuning and then sends those to each node in the cluster and make sure that they're all in sync and make sure that all the nodes in the cluster are running the proper tuning commands or the tuning operators. So these node level settings are applied on a per node basis. There's a default profile that is applied, and a default set of custom resources are applied. These default resources, in the event of the daemon failing or gracefully exiting, these are rolled back so that they don't cause any problems. So one of the things about the default CRs, custom resources, is that they're set on a node level. They're set at the node level, and they can either be based on the node or pod labels. And while using pod labels is a very convenient way to set node tuning parameters, there's a caution that that's not the best practice to do, because even though it's convenient, the Red Hat has advised us that they may deprecate that feature in a future release, and so they're really strongly recommending that we use node level tuning. So so we should stay away from pod label matching unless absolutely necessary for right now. So within the TuneD daemon, we can also do custom tuning, and we can set custom resource tuning for these modules that I have listed. So we have audio, CPU, disk, EEPC_SHE, modules, mounts, net, scheduler, SCSI host, SE Linux, syscontrol, sysfs, USB video, and VM. So those are the areas that we can set tuning parameters for. There's 3 that we can't set parameters for right now. There's the support for those are coming in future releases. All right, I think we're ready for the next slide. All right, troubleshooting builds. This is a popular topic sometimes. So when we talk about builds, I think Felicia kind of loosely talked about images as images going into the registry and the repository. So a build is the process of transforming input parameters into an object, and usually that results in an image. So the process, so when we talk about troubleshooting a build, this is usually creating an image. So there's a couple of common problems that we see when we're uh, in the build process. The first one of those is a denial of service or denial of access, denial of service, denial of access to resources. So this is caused typically by exceeding a quota at some point, either for the image or for some part of the cluster. So what we'll need to do is we'll need to do an OC describe quota to determine where we exceeded our quota. But this is the most common resolution for this error. And this will help us get by that to adjust that quota. The second most common error that we see is the service certificate generation failure. And I have the error listed here. I won't read the whole thing off because it's kind of a long, dry error. But if we see this error, what it means is that the service that generated that certificate no longer exists, or the service UUID changed. So we have to regenerate a new certificate by removing the old secret and clearing the annotations on the service. So there's a series of commands to do that. They were quite lengthy, and I didn't want to get the presentation too deep with technical details, but it's in the documentation. There's the series of commands that need to be run to reissue those certificates and follow these steps. But that's the resolution for that problem, to regenerate that certificate and get past this error. So those are the two most common build errors that we see on an Openshift platform. So we'll go to the next slide, please. All right, viewing node audit logs. So this is another one of those things that is not necessarily a troubleshooting step, but it helps with troubleshooting in that we can see the actions that are performed by users, by administrators, and by other components of the system. So we can see how the system's operating. We can see who's been making changes, who's been issuing commands to the system, so we can understand how the system's operating and what it's being asked to do. And that would help us to troubleshoot. So so the auditing system works at the API server level. It logs all the requests coming into the server. Each of the audit logs contain all of these fields. So I listed the fields. I'm not going to read all of them to just bore you, but there's some fields that have an O after the field name. Those are optional fields that may or may not have a value in them. The audit logs themselves are generated as a JSON document. So there will be an empty field for each of those optional ones if they don't have any data in them. So the JSON document will appropriately reflect that. But audit logs also give us a rich ability to go back in time and rebuild a series of actions. And so this is a very powerful troubleshooting tool that we have, especially when we need to look at a broad or a longer time period to see maybe what led up to a problem or a series of actions that may have taken some time to develop. So with that, those are some common troubleshooting things that we use, or some common things that we do in troubleshooting. And with that, that's the last one of my slides, Felicia.
Thanks, Marshall. And now we've come to the end of our presentation. I hope you all enjoyed it very much. We have some time for questions if anybody has any and wants to pop them into the chat. Otherwise, we will bid you all adieu. Let's see here. I don't see that we have too many questions. And I did want to point out to you that even though we did go over some troubleshooting issues, it's not common for you to have trouble when you're going through and installing your Openshift clusters or you're working on getting your builds put together. There's a lot of documentation out there, and the communities have a lot of things put together to help you make your transition into Openshift as smooth as possible. And although we did cover some troubleshooting issues, that it's not common for you to have it when you're first starting up. Let's see here. So let's see, how is OpenShift subscribed in public cloud environments? Joe, I see your question there about public cloud environments, but OpenShift works the same whether it's in public cloud and private cloud. It just depends on what your configurations are. If you want to shoot me an email, we can talk about it some more after we get off of the webinar. My email is on the screen, felicia.ward@techdata.com. Just shoot me an email and we'll talk about it. Okay. I'm going to go